our last speaker will share insights from applied research on circular logistics and how efficient structures and digital tools can drive real change. So please welcome Professor Uwe Clausen, Director of Fraunhofer IML.
Thank you very much, and thank you everyone for still being with me. And challenges for logistics in the circular economy. We know many locations where we distribute products to. We know from waste logistics where we have to gather things, but we still have a lot of demand to better understand the future volumes and locations of different fractions. And that is increasingly important because more and more producers are looking forward to increase the percentage of recyclates. And in order to use and to provide the secondary raw material, we have to provide more information about the quality and the composition of pollutants. And also, circular economy is not only about recycling, it's about our strategies, reuse, remanufacture, refurbish, information on suitable strategies is something that we have to connect with the distribution and the use phase of products. So a lot of coordination and logistics is about moving material and also providing information. A lot of information supply on the long term, a lot of understanding of all these smaller distributed sources of materials that we need to make circular economy work is something that we are striving, that we are aiming at. And circular value creation is complex. We need to provide tools to make it simple for industry and consumers to be successful. And looking at the supply chain, a lot of materials are pushed into the market, but the more we want to use recyclates, the more we want to apply take-back strategies, we have to provide a material flow in the other direction. Those strategies and systems, logistics systems, that can be difficult in design and technology, but they need to be simple to operate. They need to be reliable as a source of material to be competitive and sustainable. Looking at the distribution of products and usage, we have a long experience at Fraunhofer IML with optimizing distribution systems in countries and continents to understand the needed costs and the service levels. And we apply similar algorithms to design take-back systems. And now comes the age where we have to combine these two. We have to follow the products into the markets along the usage, their lifetimes, to then understand what volumes are available in which regions. And to be successful in circular economy and circular logistics means to be as regional as possible, but as concentrating volume as across regions as necessary in order to make that logistics sustainable. And this comes from a tool family called Dismod, which we have developed for many, many years, and which we will now feed with more data when better understanding the business models and the utilization of products, as we have just learned, and most of us know, go across continents for some of our products. So that's one part of design and optimization efforts that circular logistics require. The other is to understand the different qualities of the products. So we designed a tool that we call the plastics material flow calculator, and the reason to do that is we have material losses. We need to provide insight of how much input from different fractions from collection of waste are needed in what regions. And as an example, this looks like this. On the right column, you see polypropylene, the pure material. That's the ideal world, which you usually don't have. And on the very left column, you see you need 50-fold the material volume when you need to apply all the sortation and recycling. And for other fractions, the truth is in between. So the input is the desired recyclate, the amount of the specific plastic type that we need, and then we come up with the estimate of input capacity. And then we mix these calculations with the distribution in the areas, in countries, regions, and continents to design networks of collection of these fractions, and then providing the material to the specific recycling technology. And so in this specific example, it's a very large plant with 150,000 tons a year, but you see you only get a little output of the purity that you actually need. For other cases, the ratio might be better. This helps us to design downstream processes to locate and quantify the sizes of facilities, the demand for transport of the material, and it allows that circular logistics provides the supply that is competitive to virgin material in those production and distribution networks. The business idea leads to design, and a production network requires sourcing and distribution. That's known for many years. And in the recyclate-based production process, as an example of circular economy, we need to collect, consolidate, sort, recycle, and then provide the recyclate to production to close the loop. And closing the loop is also the motto of our Fraunhofer booth, so you've probably seen it already, but you haven't. Take the opportunity in the last minute of the convention to see us, because we at Fraunhofer do not only provide logistics and digitization, but also chemistry, recycling, product design, our strategies to look in a holistic way to future solutions of circular economy. Earlier today, we have heard examples from the automotive industry. I've brought an example from technical building equipment. In some cases, we even have better circulation options than recycle the materials. We can reuse or refurbish some of those materials. Examples, as you can see here, pump covers, modules, magnets, and other things. We have worked with a production company from Dortmund to identify those options, and we follow that for future products and the business models of serving them and extending the lifespan. So overall, our vision is to digitally support circular economy. We want to extend the information flow beyond production and distribution into the use phase, support business models like sharing and product service systems. We have to still work at open questions on data ownership and international standards. There is a huge push from regulation in Europe now, but there's also a lot of benefit for the customers and also benefits for companies that work towards those customer-oriented solutions. The DPP has been discussed already earlier today, can help us to understand the origin of the resources, the composition of the material, the carbon footprint, and especially the usage along the lifespan. And if we apply that for technical building equipment, we can support new business models, value-added systems. We can expand the lifespan of these products, identify parts that can still be used in newly composed new products, and the overall value chain provides a lot of opportunities for maintenance and repair, for retailers to improve their connections to customers, provide services beyond the material that they provide, and to comply with the European regulation to really make circular economy happen in the coming years. So let's together work at these building blocks to implement supply management, innovative recycling, find opportunities for repair, reuse, refurbish, better understand product design, reflecting all these opportunities, build sustainable take-back systems and reverse logistics systems, and then the Circular Valley Convention has, in my view, contributed to something that really helps us to become competitive and sustainable as an industrial reason for the years to come. So first of all, I want to thank you all for staying here until the end, but I also want to take the opportunity, being the last speaker, to thank Carsten and Circular Valley Foundation, to thank our wonderful moderator, Charlene de Bruyne, and wishing you all the very best for the rest of the day and the next Circular Valley Convention. Thank you very much.
Woohoo! Thank you, Uwe. Thank you so much.